Most of us were raised on the legend of Hitler's Atlantic Wall, 3,000 miles of reinforced concrete that was supposed to be the most impenetrable fortress in human history. We've seen the footage of the bunkers and the big guns, and we were told that D-Day was won through raw, bloody courage alone. But history suggests a much quieter, stranger reality. While the German High Command was looking out at the horizon for a fleet they couldn't stop, the Allies were busy doing something much more low-tech right under their boots. They weren't just planning an invasion, they were perfecting a piece of equipment so simple it was actually ridiculed by the men who carried it. Tonight, we're looking at why the most important weapon of 1944 wasn't a tank or a bomber, it was a common steel pipe.
If you were standing on the pebble-strewn beaches of southern England in 1943, looking across the gray expanse of the English Channel, the task ahead of you would have felt like a fool's errand. Many of us grew up hearing the stories of the Atlantic Wall, that massive 3,000-mile ribbon of concrete and steel stretching from the fjords of Norway down to the Spanish border. It was Hitler's masterpiece, a defensive line built with 17 million cubic yards of concrete. The propaganda films of the time showed an impenetrable fortress, and for the average soldier, the math just didn't add up. How do you land an army against a wall that was designed to never break? But history suggests that the most formidable walls often hide the greatest anxieties. Behind the scenes, the Allied High Command wasn't just looking for a way over the wall. They were looking for a way to make the Germans believe the wall was under attack in places it wasn't. They needed a gap, but since the Germans wouldn't give them one, they decided to invent a weapon that could create one out of thin air. This is where the story of the Canadian pipe mine, or the McNaughton Tube, begins to bridge the gap between myth and reality. While the world was terrified of the Atlantic Wall's bunkers, a Canadian general named Andrew McNaughton was looking at the problem like an engineer, which he was. He realized that the greatest weakness of any static defense isn't the thickness of the concrete, it's the predictability of the ground beneath it. McNaughton took an idea he allegedly heard from Ontario bootleggers who used hydraulic jacks to push pipes underground to smuggle whiskey and turned it into a weapon of war. By 1944, these weren't just pipes, they were invisible anti-tank obstacles. Allied engineers used hydraulic machines to bore 55-foot-long tubes horizontally into the earth, just inches beneath the surface where no German reconnaissance plane could see them. Here is the sheer scale of the deception. The Allies didn't just build a few of these, they laid over 40,000 feet of pipe. The logic was simple. You coax the enemy into thinking a stretch of road or a runway is clear and safe, a soft spot in your line. Then, with the turn of a single fuse, you detonate the pipes. In an instant, a perfectly flat road becomes a 28-foot wide, 8-foot deep anti-tank ditch. Therefore, the invincible wall was being countered by a weapon that didn't even look like a weapon. It looked like plumbing. While the Germans spent millions on visible concrete, the Allies were spending their time perfecting the art of burying the fuse. This wasn't just about blowing things up, it was about the psychological mastery of the battlefield, making the enemy feel safe exactly where they were most in danger. Have you ever noticed how the most terrifying inventions often look a bit ridiculous before they're put to use? If you had walked through a British munitions depot in 1943, you might have seen soldiers wrestling with long, spindly metal tubes that looked more like leftover plumbing from a housing project than a secret weapon. To the uninitiated, these hedgehog pipes, as they were colloquially teased, looked like a comedy of errors. They were cumbersome, they clattered, and they seemed completely out of place next to the sleek Spitfires and massive Churchill tanks. Even the seasoned veterans would joke, "What are we going to do, McNaughton? Leak the Germans to death?" But there is a specific kind of terror that comes with a static front, the kind of stalemate where neither side moves and the ground itself becomes a graveyard. Many of us remember the stories of the Great War, where men were ground into the mud because they couldn't break through simple barbed wire. By 1944, the Allies knew that if they got stuck on the beaches for even 48 hours, the German panzers would roll down from the hills and push them back into the sea. The comedy of the pipes was about to meet the very real horror of the Atlantic Wall. The reality was that these hedgehog pipes, technically known as the McNaughton Tubes, were a masterstroke of Canadian engineering designed to solve the one problem no one else could, the Czech hedgehog. You've seen them in every D-Day movie, those 6-foot-tall, jagged iron crosses made of railroad tracks welded together. The Germans had planted nearly 1 million of them. They weren't meant to kill men. They were meant to rip the bottom out of landing craft at high tide and stop tanks at low tide.
The Allies realized that clearing these obstacles by hand with satchel charges was a suicide mission. An engineer would have to run out under machine gun fire, set a charge, and hope for the best. Therefore, McNaughton's ridiculous pipes were designed to be pushed horizontally through the sand using hydraulic jacks. Instead of a man running into the line of fire, the pipe did the work. A team could stay in a shallow trench or behind a tank and drive these explosive-filled tubes 50 to 100 feet forward, right under the feet of the German defenders and directly beneath those iron hedgehogs. When they detonated, it wasn't just a bang, it was a localized earthquake. The pipes didn't just break the iron, they liquefied the ground beneath them, causing the obstacles to sink into the earth or be blown skyward. The terror of the static front was solved by the comedy of the pipes. In the British and Canadian sectors where these were deployed, they cleared paths in minutes that would have taken hours and hundreds of lives using traditional methods. The Germans had spent years building a static defense that relied on the ground staying put, but the Allies, with their plumbing, had learned how to make the very earth move. Because these pipes proved the Allies could manipulate the terrain itself, the focus shifted from merely breaking the wall to a much more ambitious goal. If they could bury a fuse to destroy a beach, could they bury a secret deep enough to fool the entire German high command? This leads us directly into the heart of the greatest invisible project of the war. We often celebrate the triumphs of ingenuity, the moments when a brilliant idea sparks into existence and solves an impossible problem. But history, if you look closely enough, is far more often shaped by the stubborn refusal to accept defeat. The McNaughton tube, for all its revolutionary impact, wasn't born from a moment of pristine inspiration. Instead, it emerged from a chorus of frustrated sighs, abandoned blueprints, and the crushing weight of previous failures. To understand the genius of silent engineering, we must first grasp the sheer desperate futility that preceded it. Imagine a room full of the brightest military minds, staring at maps of fortified coastlines, knowing that millions of lives hinged on finding a flaw in the impenetrable. Every conventional weapon, every textbook strategy had been considered and found wanting. The beaches of Normandy weren't just defended by concrete, they were defended by the collective grim knowledge that every frontal assault since the Great War had ended in catastrophic slaughter. The silence that the McNaughton tube promised wasn't just about a stealthy approach, it was about silencing the enemy's guns by removing their targets before they even knew they were there. But achieving that silence required a long, hard look at what hadn't worked. The initial attempts to breach the Atlantic Wall were, frankly, disastrous. Many of us remember the stories of Dieppe in 1942, a raid intended as a reconnaissance in force, which instead became a bloody lesson in the Germans' defensive prowess. Canadian troops, in particular, bore the brunt of that failure. Tanks got bogged down in the shingle. Infantry were cut to pieces by machine guns from concrete bunkers. The very idea of a direct assault became synonymous with suicide. The problem wasn't a lack of courage, it was a lack of effective tools. This is the crucial fact for understanding the birth of the McNaughton tube. The lessons of Dieppe screamed one undeniable truth. You cannot send men and machines against hardened fortifications without first neutralizing the defenses silently and from a distance. The conventional wisdom of softening up defenses with aerial bombardment proved woefully inadequate against reinforced concrete. Bombs created craters, yes, but they rarely destroyed the deeply embedded firing positions or the ubiquitous Czech hedgehogs and mines. Therefore, the engineers knew they needed a weapon that could operate under the defenses, out of sight and out of range of enemy fire. General McNaughton, a highly respected engineer himself, was keenly aware of these limitations. He rejected several early concepts that were either too slow, too noisy, or too vulnerable. One notable early attempt involved sledges carrying explosives that were supposed to be dragged across the beach. These were quickly discarded after tests showed they either got stuck, broke apart, or were easily spotted and destroyed. Another concept, the conger torpedo, while effective against obstacles, required a specialized vehicle and still presented a visible target. It was the engineering equivalent of trying to fix a leaky pipe with a sledgehammer, when what was truly needed was a scalpel. The breakthrough for McNaughton came from recognizing the failure of brute force. Instead of trying to smash through the wall, he envisioned going under it. The idea of horizontal drilling wasn't new in itself. As mentioned, it was even used by bootleggers. But adapting it for military use, specifically for explosive delivery, was revolutionary. The problem wasn't merely pushing a pipe, it was doing so quickly, quietly, and effectively in sandy, unpredictable beach terrain. The engineers tasked with developing the McNaughton tube had to overcome several reward challenges that pushed the boundaries of their time. For instance, the earliest hydraulic jacking systems were cumbersome and prone to breakdown under the pressure of pushing a long, heavy pipe filled with explosives. They required significant improvements in hydraulic pump technology and the development of robust yet lightweight steel tubing that could withstand immense strain without buckling. The sheer physical length of the pipes, often 50 to 100 feet, meant that even minor deviations in the drilling path could render them useless. This led to the development of specialized pilot heads that could guide the pipes with remarkable precision, even through shifting sands.
Furthermore, the explosive itself was a challenge. They needed a charge that was stable enough to be pushed through the ground, but powerful enough to create a massive crater. Therefore, the silent aspect also extended to the charge itself. It had to be detonated electrically to avoid any audible fuse mechanisms that could alert the enemy. This integration of hydraulic power, robust material science, and precise explosive technology represented a quiet, almost invisible revolution in combat engineering. It was a weapon system born not of an initial flash of genius, but from the painstaking, iterative process of learning from every single failure and refusing to be confined by conventional thought. Because the McNaughton tube was engineered in silence, born from the failures of previous visible methods, it created an unforeseen opportunity far beyond just clearing beaches. It established a precedent for a different kind of warfare, a psychological battle where the mere threat of the unseen could be as devastating as the blast itself. This precise, quiet engineering became the foundation for the most elaborate and successful deception campaign in military history, leading us to how the Allies managed to fool the entire German high command about where and when the real invasion would strike.
War, at its most fundamental level, is a game of resource management. Many of us who have spent a lifetime in industry or management know that you can have the best product in the world, but if your logistics fail, you have nothing. In 1944, the Allies faced a logistical paradox that seemed unsolvable. They were preparing for the largest amphibious invasion in human history, an undertaking that required millions of tons of steel, fuel, and food. The problem was that an operation of this magnitude is impossible to hide. You cannot move 1,000,000 men to the coast of England without the enemy noticing. The German High Command wasn't stupid. They had their eyes on the ports, their ears to the radio, and their planes in the sky. If Hitler knew exactly where those resources were headed, he could simply slide his elite panzer divisions, the mailed fist of the Third Reich, to that specific spot and wait. The Allies realized that to win the physical war, they first had to win a ghost war. They had to feed the enemy a diet of lies so convincing that the Germans would starve their own front lines of the reinforcements they desperately needed. This wasn't just a matter of telling a tall tale. It was a feat of logistical engineering that involved building an entire army made of nothing but air, wood, and rubber. The result of this necessity was Operation Fortitude, a masterclass in deception that utilized what we now call the Ghost Army. But the real reward in understanding this story isn't just the inflatable tanks, it's the logistical commitment to the lie. To make the Germans believe that a massive force, the first U.S. Army Group, FUSAG, was stationed in Kent and headed for Pas-de-Calais, the Allies had to treat that ghost like a living, breathing organism. Think about the sheer detail required to fool a German intelligence officer. It's not enough to put a rubber tank in a field. You have to create the evidence of an army. Therefore, the Allies didn't just deploy decoys, they deployed logistics. They built dummy fuel depots made of plywood and canvas. They constructed fake mess halls where no one ate and fake hospitals where no one was treated. They even went as far as using track-making machines, essentially tractors with specialized plates, to drive back and forth across muddy fields, creating the deep ruts that thousands of heavy trucks and tanks would naturally leave behind. A real army group generates a massive amount of chatter. To mimic this, a small group of specialized signal corps officers operated spoof radio networks. They transmitted hundreds of thousands of mundane messages, requests for more socks, reports on truck repairs, even fake sports scores between units that didn't exist. They were feeding the German listeners a mountain of logistical noise. The Germans, meticulous as they were, mapped every single one of these fake signals. They became convinced that General George S. Patton, the commander the Germans feared most, was leading this phantom force. The Allies fed this ghost army so well, the German High Command made a fatal logistical error. They kept the 15th Army, over 150,000 men and hundreds of tanks, stationed at Pas-de-Calais to wait for Patton. Even after the landings began at Normandy, the Germans believed the D-Day fleet was just a diversion. They were so convinced by the logistical footprint of the Ghost Army that they refused to move their panzer divisions south. By the time the Germans realized they were fighting a ghost in the north, the real logistics of the Allied invasion had already secured the beachhead. Those panzer divisions, which could have crushed the Normandy landings in the first 48 hours, stayed put, starving the actual German defenders of the strength they needed. The Allies hadn't just outfought the Germans, they had outmanaged them. They used the enemy's own obsession with order and intelligence against them, proving that in war, what you don't see can be just as lethal as what you do. But while the High Command was focused on the grand map of Europe and the movements of ghost armies, a much more literal and dangerous form of invisible logistics was being perfected beneath the very boots of the soldiers on the front.
If the Ghost Army was the distraction, the McNaughton pipes were the hidden blade, and they were about to be used in a way that defied every rule of conventional warfare.
If you've ever spent a Saturday morning working on a stubborn, clogged drain or trying to run a new water line under a driveway, you know that the ground beneath our feet is rarely as cooperative as it looks. Now imagine trying to do that same job while wearing 40 pounds of gear under the cover of a pitch-black moonless night with the constant threat of a German S-mine, the infamous Bouncing Betty, waiting to greet your shovel. In the frantic months leading up to June 1944, the Allies faced a terrifying reality. The beaches of Normandy were a labyrinth of obstacles, but the ground behind the beaches was even worse. The Germans had turned the coastal exits into kill zones by pre-aiming every artillery piece at the few roads leading inland. Many of us understand that a bottleneck is a death sentence in any operation. If the Allied tanks couldn't get off the sand and into the fields, they were sitting ducks. The problem wasn't just the wall, it was the artery, the logistical flow of men and machines that had to move inland instantly. To save those lives, the Allies needed a way to turn the very ground the Germans were standing on into a powder keg without ever showing their hand. They needed to move through the earth itself. The solution was a feat of blue-collar engineering that sounds more like modern telecommunications work than 1940s warfare: horizontal drilling. The McNaughton tubes weren't just tossed onto the sand, they were driven into the earth using specialized hydraulic forcing jacks. These machines were the hidden artery of the operation. A standard McNaughton unit consisted of 2-inch diameter steel pipes, usually in 5-foot sections. These were threaded together and pushed horizontally through the soil by a hydraulic jack that could exert several tons of pressure. It was a slow, rhythmic process. Push 5 feet, stop, thread on a new section, and push again. In the soft, silty soil of the French coast, an experienced crew could bore a hole 60 or 70 feet long in a matter of hours. But why go to all that trouble just to bury a pipe? Because the payoff was the element of surprise. By drilling horizontally, the Allies could place hundreds of pounds of high explosive directly underneath a German paved road or a reinforced concrete pillbox without disturbing the surface. Therefore, to a German sentry looking out over the landscape, everything appeared perfectly calm. There were no fresh mounds of dirt, no telltale trenches, and no signs of sabotage. The powder keg was literal. Once the hole was bored, the steel pipe was filled with 808 plastic explosive or TNT canisters. Because the explosive was confined within a steel tube underground, the physics of the blast changed. Instead of the energy dissipating into the air, the ground acted as a tamping agent, forcing the entire force of the explosion upward. One of the startling facts from the engineering reports is that a single 70-foot pipe could create a crater nearly 30 feet wide. On D-Day, this meant that the Allies didn't just have to clear obstacles, they could literally erase them. In sections of the British Gold and Juno beaches, these pipes were used to instantaneously create instant anti-tank ditches across German counterattack routes. When the German panzers tried to rush the beachhead to push the infantry back, they suddenly found the road had vanished into a smoking chasm. The hidden artery had worked. By using horizontal drilling to turn the landscape into a weapon, the Allies ensured that the veins of the German defense were severed before they could ever be used. It was the ultimate dirty trick played by men who knew that on the battlefield, the most important work happens where nobody is looking. This invisible infrastructure worked so flawlessly, the engineers who had once been the butt of plumbing jokes were suddenly the heroes of the breakthrough. But as the smoke cleared and the invisible wall was finally breached, it led to a profound realization. The hedgehog pipes hadn't just cleared a path through the sand, they had cleared a path for a new kind of warfare, one where the most ridiculed weapons would end up having the last laugh. In the high-stakes world of military procurement, there is often a bias towards the Goliath, the massive tank, the heavy bomber, or the sophisticated radar system. Many of us who have spent years in competitive environments know that the simplest tools are often the easiest to overlook, or worse, to mock. Throughout 1943, the McNaughton tube was the David of the Allied arsenal, and it was treated with about as much respect. British and American officers, accustomed to the raw power of the Bangalore torpedo or the sheer force of naval shelling, looked at these skinny steel pipes and the plumber's jacks that drove them with a healthy dose of skepticism. The soldiers tasked with training on them were often the target of barracks humor. They weren't warriors, they were well diggers. But as the sun rose over the chaotic carnage of the Normandy coast on June 6, 1944, the laughter stopped. The sophisticated plans were falling apart in the surf, and the Allies were facing a terrifying reality. The heavy equipment was sinking, and the men on the sand were pinned down. In that absolute crisis, the success of the invasion didn't rest on a heavy bomber, it rested on a pipe. McNaughton Tubes' last laugh is found in the cold, hard numbers of the Juno and Gold Beach sectors. While the American experience at Omaha Beach became a legendary tragedy due to the failure of tanks to land and the reliance on traditional hand-placed charges, the Canadian and British sectors had a secret weapon that actually made it to the shore. On Juno Beach, the 6th Canadian Armored Regiment and the supporting engineers didn't have to wait for the tides to recede to clear obstacles. Because the McNaughton tubes had been preloaded into specialized AVRE tanks or carried in sections by small teams, they were deployed under the teeth of the German defense.
The value of these pipes was life itself. A traditional Bangalore torpedo, the long hand-carried explosive tube, required a soldier to crawl out into the open, slide the pipe under a wire entanglement, and light a fuse while being an easy target for a sniper. It was a one-for-one trade. You cleared the wire, but you often lost the man. However, the McNaughton tube, pushed from the safety of a shallow trench or from behind the hull of a stalled tank, could clear a 20-foot wide path through a minefield or a hedgehog array without a single Allied soldier exposing their head above the sand. The weapon that had been ridiculed as plumbing became the primary reason the Canadians were able to move off Juno Beach faster than almost any other unit on D-Day. They weren't just clearing paths, they were creating lanes of life. By 10 a.m., while other sectors were still struggling to find a foothold, the Canadians had used their pipes to breach the seawall and were already pushing into the town of Bernières-sur-Mer. The last laugh was a grim but triumphant one. After the war, German officers who were captured at the Atlantic Wall expressed bewilderment at how their invincible minefields and tank traps had been neutralized so quickly in certain sectors. They had prepared for an assault they could see. They had no defense against an assault that came from 18 inches underground. The ridiculous pipe had done what the heavy bombers couldn't. It had systematically dismantled the German defense from the bottom up. Because the McNaughton tube proved that a simple, well-engineered solution could outperform a million-dollar fortification, it changed the way we look at military innovation. It wasn't just a win for the Allies, it was a win for the common-sense engineer. But as the guns fell silent and the beachheads became museums, the story of the pipe mine began to fade into the shadows of more glamorous history, leaving us to wonder what else we might have forgotten about the architects of the unseen. As the years roll by and the memories of 1944 move from the first-hand accounts of our fathers and grandfathers into the silent pages of history books, we often find ourselves drawn to the grandest monuments. We visit the massive concrete bunkers that still squat like gray ghosts along the Normandy coast, and we stand in awe of the sheer scale of the Atlantic Wall. It is human nature to remember what we can see,
But many of us who have lived through the shifts of the last several decades know that the most profound changes in the world often happen beneath the surface, quietly, without fanfare, and away from the cameras. There is a specific kind of tragedy in the fact that the men who won the engineering war on D-Day are rarely the ones with statues in the town squares. They were the architects of the unseen, the ones who realized that to defeat a monster of concrete and steel, you didn't need a bigger hammer, you needed a smarter way to move the earth. Today, as we look back, we have to ask ourselves, why did a weapon as effective as the McNaughton tube vanish so quickly from our collective memory, and what does its invisible legacy tell us about the way we face challenges today? The legacy of the McNaughton tube is not found in a museum display of twisted metal. It is found in the very doctrine of modern warfare and civil engineering. The reward for those who look closely is the realization that this ridiculous pipe was the ancestor of nearly every tactical breaching system used today. If you look at the modern McLick, a rocket-propelled line of explosives that clears minefields in seconds, you are looking at the direct spiritual successor to General McNaughton's pipes. The core logic remains unchanged. Don't send a man to do what an explosive artery can do from a distance. Therefore, the invisible warfare pioneered on the beaches of Juno and Gold changed the DNA of the combat engineer. They moved from being laborers of the front line to being the surgeons of the battlefield. But the legacy goes beyond the military. There is a purple value in acknowledging how this wartime desperation accelerated our mastery over the earth itself. The techniques perfected by those Canadian and British engineers, horizontal drilling under immense pressure, the use of hydraulic jacks to navigate unpredictable strata, and the precision placement of infrastructure without disturbing the surface, became the foundation for the modern trenchless technology that runs our world today. Every time a fiber optic cable is laid under a busy interstate or a new water main is pushed beneath a suburban neighborhood without tearing up the asphalt, we are seeing a descendant of the McNaughton tube at work. The final salute belongs to the men who were comfortable being ridiculed if it meant they could save a life. Men like General Andrew McNaughton and the thousands of nameless sappers who lugged 5-foot sections of steel through the surf. They didn't seek the glory of the ace pilot or the tank commander. They were content to be the plumbers of the invasion. The most effective solution isn't always the loudest one. Sometimes the way to overcome an invincible wall isn't to climb over it or smash through it, but to have the humility and the wit to simply go beneath it. As we look out over the peaceful beaches of Normandy today, where the sand has long since covered the craters and the pipes have rusted into the soil, we honor not just the strength of the Allied arm, but the brilliance of the Allied mind. They were the architects of a victory that the enemy never saw coming, and for that, they deserve the last word. The story of the pipe mine reminds us that history is often written in the things we choose to ignore. While the world looked at the Atlantic Wall, the Allies looked at the dirt, and in that simple shift of perspective, they found the key to a continent. History has a way of burying its most important lessons in the sand, much like the pipes we've discussed today. But stories like this only stay alive if we choose to pass them down. If you appreciate this kind of deep dive into the grit and ingenuity of the greatest generation, I'd be honored to have you join our community. Subscribe to the channel so you don't miss our next investigation into the forgotten mechanics of our past. And more importantly, I want to hear from you. Many of you watching likely have your own stories, perhaps passed down from a father or an uncle who served in the engineers or worked in the trades that made these inventions possible. Leave a comment below and let's keep this conversation going. Your perspective is what keeps this history from truly being unseen. Thank you for watching, and I'll see you in the next one.